Welcome to JavaScript Bytes on Learn Awesome, where we solve JavaScript problems in small, easy to follow videos. Today we'll learn how to fetch an image using JavaScript and apply a grayscale effect using two different methods, one with CSS filters and another with the Canvas API. Let's get started. So here we are in Visual Studio Code and we have created a file called applygrayscale.html and another file called applygrayscale.js. Let's create some boilerplate code in the HTML by typing HTML, selecting the second entry and changing the title. Let's add a script reference to our JS file and we are done. Right, so this file includes a script tag that links to applygrayscale.js where we'll write our JavaScript code. So let's move to that file. All right, now I'm going to write some code to fetch an image. All right, we are done. So we are fetching an image from pixum.photos, which is a random image website, converting it into a blob and displaying it. Once it loads, we apply grayscale using both CSS and Canvas. We are not going to go in full details of fetching an image as we have a dedicated video on our channel about it, which you can refer to. So we are going to focus on the grayscale part. So let's first focus on the CSS grayscale part. And let me write the appropriate function. All right, so with just one line, filter colon grayscale 100%, we apply a grayscale effect. This method is fast and efficient, perfect when you don't need to modify pixels directly. And that is what we are going to solve with our next approach, that is applying grayscale using Canvas. So let me demonstrate using the Canvas API to manually process the image's pixels and applying grayscale. Shift Alt F to format the code. Let's break down what's happening in this code and let's talk about Canvas first. A canvas is like a blank drawing board in your browser. It's an HTML element with a canvas tag that lets you draw shapes, images, and animations using JavaScript. So this line would result in something like, now obviously it won't have my canvas ID, but doesn't matter. So the real deal is, unlike an image, you control every pixel on a canvas with JavaScript. So we create a canvas element in JavaScript, get its 2D drawing context, which allows you to draw and manipulate images. Note the difference. The context is the object that provides functions to draw shapes, text, and images. 2D means we want a 2D drawing surface instead of 3D WebGL graphics, and we use this context to draw, manipulate, and extract image data. Now note that when we do create element with canvas type, the canvas created is tiny. Since we want it to represent our image, we resize it to match the image dimensions. So we make its width equal to image width, height equal to image height. And next, we draw our current image in color form on the canvas using the context. Okay, now things get interesting. After the image has been drawn on the canvas, we get its pixel data. So getImageData gives us an object with all the pixel information, and it is stored in an array where every four values represent a pixel's red, green, blue, and alpha transparency. And note the image data is not copied by reference, it's a copy of the pixel values of the image. So changing the pixel values on this object won't result in the canvas being affected directly. Okay, now things get really interesting. We are applying the grayscale effect manually. So what we are doing to make the image grayscale, we take average of red, green, and blue values for each pixel and assign it back to all three channels. So if you look closely in the loop, we are iterating over the four values and taking average of RGB and setting the average back to R, G, and P. A very logical question at this stage would be, how does that make an image grayscale? So note that we perceive color as a difference of brightness in red, green, and blue colors. By averaging the red, green, and blue values, we get a single brightness level. Since we set all three channels of the pixel to the same value, the color or perception of color disappears, leaving only some shades of gray. We apply the same technique on every pixel of the image, and the entire image turns grayscale as a result. Alright, once we are done doing that, we update the canvas with the modified pixel data using the putImageData function and display the image on the page using a parent child. As you can see, this gives us full control over image manipulation at the pixel level. We are just talking about grayscale here, but you can do all sort of image manipulations or pixel manipulations using the data available to you. The problem, however, is that it is more complex and slightly slower since there is computations involved. So which one should you use? Well, when you need a quick grayscale effect, use CSS filters as they are fast and simple. But if you need pixel level control, use Canvas API for advanced effects. Time to see the result of our effort. So let me drag drop the HTML file in Chrome. Okay, something is not right. Yes, there was a mistake. I did imagedata.pixels. It should have been imagedata.data. So let me go back and refresh. And here we are. We are seeing the original image, the image turned grayscale by CSS, and image turned grayscale by our Canvas API. And that's it, folks. Today we learned how to fetch an image and apply grayscale using two different approaches, CSS for quick effects and Canvas for full control. Try modifying this example to create sepia, brightness, or contrast effects. Thanks for watching JavaScript Bytes. See you in the next one.